karanjetlilive.
Hi guys, welcome to my channel, and today in this video I'm going to explain you about different CPU registers. So guys, for the full video all of you stay tuned. So guys, in this video we will discuss the CPU registers used by Intel 8085 processor. Okay, so guys, no matter which registers we discuss, okay, but more or less all the CPUs, they have similar registers which perform the similar functionality, whether it is 8085 or it is the higher models of the processors. Okay, so their basic functionality, their names can be different, okay, their sizes can be different, but their basic functionality is the same. Okay, so guys, in this example we will discuss 8085 registers, CPU registers of 8085 processor family. Okay, so guys, in 8085 the register size is 8 bit, is 8 bits. The CPU registers in Intel 8085, their size is 8 bits. Okay, so it has a program counter, we call it as PC, program counter. It has one program counter. Okay, so then it has MAR, we call it as memory address register. Okay, so it is also 8 bit. It has a MBR, we call it as memory buffer register. So it has a program counter, it has MAR, it has MBR. Okay, so after this it has IR, we call it as instruction register. It has IR, we will call it as instruction register, and it has accumulator. It is also called as register A. We call it as accumulator. Okay. So other than all these registers, so in the next part of the video I'm going to explain you what is the purpose of these registers and what functionality they perform. Okay, so before we move to that, it has another, we call it as SP, or we call it as stack pointer, or we call it as stack pointer, and it has status flag. So it is also a 8-bit register, we call it as status flag. Okay, so these are the purpose specific registers. So these registers, they have some specific functionality. What functionality they have, we will discuss it. So other than this, it has general purpose register. So it has 6, like this, it has 6 general purpose register. Okay, so that is BC, HL and DE. So these are general purpose registers. They can store some temporary data, temporary variables and all those. Okay, and each of them is 8 bit, and each of them is 8 bits. So they can work single as a 8-bit register, like B can work as a single 8-bit register, or they can also work in a register pair. We call it as register pair. So then they become together 16-bit. So BC register pair is 16-bit. HL register pair is 16-bit. DE register pair is also 16-bit. Okay, so guys, these are the CPU registers. These are the CPU registers. We have a program counter, we have memory address register, we have memory buffer register, we have stack pointer, and we have status flag. We have an accumulator, we have an instruction register, and we have some general purpose register which can store temporary data or variable. They can work as single register, only be for 8 bits, or we can make them work as pairs. We can combine them together to make as the register pair, and the register pair becomes a 16-bit registers. Okay, so guys, I hope it is clear up to here. So here we discussed the different registers. Now next part of the video I will tell you what is the functionality of each register with the help of example. So guys, now to explain the functionality of each register, I will take this example and I will tell you what this register does and what type of data it stores and what is the functionality of this register. Okay, so guys, the first register which comes is called as program counter. Okay, so in the previous part of this video, I gave you the full form all of them. Okay, so for again quickly, program counter, IR stands for instruction register, MBR memory buffer register, stack pointer, accumulator, it is also denoted by MAR memory address register, and status flag. Okay, so coming to the point. Okay, program counter. Okay, so guys, what is a program counter? So program counter is the register which stores the address of next instruction which the CPU will process. It stores the address of next instruction which CPU will process. Suppose presently CPU is here. This is the present instruction. This is the present instruction. And what, by the way, this is our memory. This is our memory. These are the memory addresses. And here is our program stored. Here is our program stored and here is some other data stored. Okay. You know, in the memory we can store programs, we can store data and different data structures which are required. Okay. And suppose this is the present instruction. So what program counter stores? It stores the address of the next instruction. Now this is the present instruction. What is the next instruction? This. What is the address of next instruction? This. 120. So what program counter will store? 120. Program counter stores the address of next instruction. Then coming to IR, instruction register. It stores the present instruction. It stores the present instruction. So what is present instruction? Move immediate B, 6. Move immediate B, 6. This is the present instruction. Okay. Program counter will point to the address of next instruction. Instruction register will store the present instruction. Then comes MAR, memory address register. What it stores? It stores the address of the present instruction. Now what is present instruction? Move immediate B, 6. What is the address of present instruction? 110. Now guys, keep in mind, MAR will store the address of the present instruction and program counter will point to the next what is coming after this. Okay, then comes MBR. Then comes MBR, memory buffer register. Memory buffer register. So guys, anything what we bring from the memory to the CPU is first stored in MBR. If is first stored in MBR. For example, before I am explaining you, we brought this instruction here. Okay, because then only it became the present instruction. So it will have MVI B, 6. Then from here we moved it to instruction register. From here we moved it to instruction register. So right now it is holding the last data or the recent data which we brought to the CPU, which we brought data or instruction which we brought to the CPU. So MBR is a temporary storage of data. Anything which comes from the memory to the CPU is first stored in MBR. Anything which goes from the CPU register to the memory is stored in memory buffer register. Then comes accumulator. So guys, what is accumulator? Accumulator is a special register which is part of your ALU, arithmetic and logic unit. Okay, it is used as a source of data for the arithmetic operation. It can be used as source of one data for the arithmetic operation, and it can also be used as the destination of the result after the arithmetic operation. So for example, here if we see this program, move immediate a comma 5. So one data we are moving in accumulator. Okay. Another data we have to move in register B. Another data we have to move in register B. So then if you see the instruction add B means whatever is there in accumulator. What is there in accumulator? B5. To that you add the content of register B. So what should be in register B? 6. 5 plus 6 and store the result in accumulator. So guys, for your reference I am telling you accumulator works as a source of one operand and after the arithmetic operations destination of the result. How it works, how it does, for that I am going to make another video of a instruction cycle. I will divide it into two parts. One is fetch, another one is execute cycle. So in execute cycle I will explain you in detail how accumulator works. Just for the time being you consider it accumulator stores one operand, okay, and after the arithmetic operation is done it stores the result of the operation. It stores the result of the operation. So guys, then comes stack pointer. Then comes a stack pointer. So what is the job of stack pointer? Now again, why do we need stacks? What is job of stack pointer? For that I'll make another video. Basically stacks are very important for the working of your CPU. Okay, so when the CPU jumps from one program to another, from another to another, when the interrupts are taken care of, then stack pointer plays a very important role. Okay, for the time being, what we will tell, what is a stack pointer? It points to the top of the stack. It points to the top of the stack. Where is our stack? What is the top element of the stack? It will store the address of it. Now here in the memory, so our stack is stored, it starts at 400. So here is the top. Here is the top. So where the top value is stored? It will be stored in stack pointer. So what is the top here? So what is the address of top? 400. So what will be stored in stack pointer? 400. 400. So again quickly, program counter points to the next instruction. Instruction register stores the present instruction. Memory address register stores the address of the present instruction. MBR, it stores anything which comes from the memory first, then from here it goes to the concerned CPU register, or anything which wants to go, we want to send from the CPU registers to the memory. First it is stored in MBR. It is like a temporary buffer, like all the data which comes to the CPU is stored here first, and all the data which goes to the CPU is stored here first. So the job of MBR in detail we will explain, as I told you, in instruction cycle, in the fetch phase. So what happens in the fetch? MBR plays a important role. For that my next video is coming. Stack pointer points to the top of the stack. Okay, so wherever your stack is stored, CPU stack is stored in the memory, so this will point to the top address of the stack. Now here my stack is stored at 400 position and it grows downwards, and here is my top of the stack. Here is my it grows upwards, and here is my top of the stack, and it is pointing to the top. Okay, now coming to this status flags. So guys, what is the job of status flag? They store the status of the operation. So whenever we perform any arithmetic operation or whenever we perform any logical operation, so what is the status of the result of that operation? That is stored in status flag. That is stored in status flag. So guys, status flag, okay, status flag here, these 2 points, they are empty for the future purposes. Okay, so right now, so how many status flags we have? 5. Right now how many status flags we have? We have 5 status flags. So one is S. S is called as sign bit. S is called as sign bit. If it is 0, it means the status of the result. So if we added 2 operations, okay, and the status is 0, it means S is 0, it means the result of the arithmetic operation was positive number. The result of the arithmetic operation was a positive number. If it is 1, sign bit is 1, it means the earth of the result of the operation was minus. The result of the operation was minus number. Okay, for example, we add 5 plus 6 gives us plus 11. So then S will be 0. If I subtract 5 minus 6, it is minus 1. So what is the result? The sign bit will be 1. It means the result is negative. Then the next status flag, 0. If I subtract 5 minus 5, then the result is 0. Then this becomes 1. Then this becomes 1. It will tell us the result of this operation was 0. We need all of them. Okay. Why we need them? For that, for comparison, testing and so on. So when we do the instruction cycle part 2, the execute cycle, then we are going to explain you these in detail. Then we have AC. Then we have AC. What is AC? It stands for carry. It stands for alternative carry. Means if we added two numbers and a carry bit is generated, which should be added as a third number to the next bit, then this becomes 1. This becomes 1. It tells a carry has been generated. It tells a carry has been generated. For example, we are adding two binary numbers. Okay, so 1 plus 1 gives us 0, and there is one carry which is generated, and it must be added to the next number. So then this bit will become 1. Then this bit will become 1. It will tell us there is a carry which should be taken care of and added to the next bit. If there is no carry generated, for example, this is 0. 0 plus 1 is 1. Carry is nothing but 0. Then this bit becomes 0. Basically, whatever operation we are doing in the CPU, it will reflect the status of the result. It will, whether it is negative, it is positive, whether there is carry and so on. Okay. So then comes P. It is called as parity bit. It is called as parity bit. So guys, all of you know what is a parity. Parity is used for error detection. It is used for error detection, and in computer organization, even in our network, we have two types of parity: even parity and odd parity. So whatever we have agreed on, whether we are agreeing on even parity or odd parity. Okay, so this bit, P bit, will set the value to 0 or 1. If we are agreeing on even parity, then it will set, and even parity is generated, then it will become 1, else it will remain 0. For parity bit also, guys, there is a separate video tutorial which I'll be uploading. So what is a parity bit, how it is generated, and how it is helpful for us. Okay, so then we have the last bit. We call it as CY bit. So what is CY bit used? It is also a carry bit. But what is a carry bit? What type of carry bit it is? Okay, so guys, this carry bit is set to 1 if the numbers, both the numbers, here we look at the numbers, they both have 4 bits. Okay, for example, this is 1 plus 0, 1, 1, 1, 1. Now, again a carry is generated, which cannot be adjusted since both the numbers are 4 bit. Means carry is bigger than the total number of bits. Okay, so then this bit becomes 1. Since these registers are 8 bit, and in this example I am showing you 4 bit, means if we have a 8 bit number and the result which is generated is a 9 bit, for example, blah blah blah, and here we generate a carry. Okay, so which is bigger than the representation, range of representation, then this becomes 1. For example, we are adding two 8-bit numbers, but the result is 9 bits. So 9th bit cannot be adjusted. So then this becomes 1. Then we do the necessary steps for adjustment of the 9th bit. So then this status, it becomes 1. So the AC and CY, they both are related to carry bit. In case of AC, if we want to add the carry to the next bit, then this becomes 1. And in CY, if the extra carry is generated which is bigger than the total range of representation, okay, so then this bit becomes 1. Okay, so guys, I hope you understand it. Okay, so too much of information in this short video. Okay, so the main concern of this video, the main topic was different CPU registers and what is their functionality. So in CPU we have program counter, stores the address of next instruction. IR stores the present instruction. MAR stores the address of the present instruction. MBR is the temporary storage of data, any data which comes from the memory to the register and which goes from the register to the memory stored here first for some period of time. We have stack pointer, points to the top of the stack. We have accumulator which is used as a source of one operand, and after the arithmetic operation it is also used as destination of the result. And then we have status flags. So what is status flag? They tell you about the status of the result of a arithmetic operation or any instruction which has been executed by the CPU. And it has 5 active bits: S bit, sign bit, it is 1 if the status is negative number, it is 0 if the number is positive. If the result of the operation is 0, then it becomes 0 becomes 1. Okay, if there is a carry generated which should be added to the next bits, then AC becomes 1. If we agreed on even on odd parity, depending upon what parity we agree, the status will become 1 or 0. And CY, in case we are adding two 8-bit numbers and the result is 9 bits, if the 9th bit is generated, then this becomes 1, so that we can take the necessary steps to adjust that 9th bit. So guys, I hope I made myself clear and I hope you understand it. So guys, if you like my videos, if you understand it, then please subscribe to my channel. I'll be uploading more and more lectures related to digital electronics, operating system, system analysis and design, computer organization and architecture, okay, and all many other topics related to information technology. So guys, thanks for watching and all of you stay tuned.